Dimensions, not measurements or the dimension in physics that you know, but today I'm going to talk about the dimensions, the extent to which an object can move in space. So let's visualize. We have the zero dimension, that where an object is static. Then we have the first dimension, which is a single line where an object has 1 degree of freedom, it can only move left to right. Then we have the second dimension, which has coordinate x and y, the one we're more used. And here an object has 2 degrees of freedom where he can move, and it is expressed in a sheet of paper. We are used to in the second dimension see things like cartoons, video games. Those are examples of things in the second dimension, in 2 dimensions, 2D as we say. Followed by a third dimension where we have 3 lines, 3 coordinates x, y, and z perpendicular to each other. Just imagine it like the corner of a house where you have the 3 lines perpendicular to each other. There we visualize many things. It is made of a length, a width, and a height, and practically everything around us are in 3 dimensions, 3D as we call it. And this notion of 3D with 3 coordinates, length, width, and height were used to make things like video games or 3D cartoons. Then we have the 4th dimension. I know Einstein's theory of relativity says time is the 4th dimension, but here I want to talk about spatial dimension, not temporal dimensions. It means if I want to locate you, I'll ask you where are you, not when are you. Okay, here you imagine 4 lines, all of them perpendicular to each other, and where we have coordinate x, y, and z. It is difficult to imagine, but just deal with it. Here a particle has 4 degrees of freedom, and when taking 2 coordinates at a time, you can have this. If you try to visualize a simple cube in 4-dimensional form, you can have this a hypercube, or in this form a tesseract.